Good afternoon. Hi.
Hello, good afternoon, Doc.
Yeah, I was actually surprised. I mean, I'm not sure where. I don't know if you had another class or something. Noticed I was about to send an email, but suppose it's a good thing I held on to this because okay. So I see people have just joined. All right. I wonder if people were out for lunch or something. So maybe we can start. But before we start, I just wanted to find out if somebody could just confirm if you can hear me just fine, and also if you can see my screen as well. So I've just shared my screen. You should be able to see my screen, I guess.
Yes, Doc, we can see your screen.
Okay, great, thanks. And again, I think I broadcast from a completely different location, and I have this very nice setup with a nice microphone here. I hope I'm audible enough today as well. Yeah, I hope I am. Anyway, um, so yesterday when we met, we mostly discussed this whole notion of cloud computing. So that discussion is actually tied to a reminder here. The discussion is tied to our broader discussion of so-called the technological infrastructure linked to management information systems, and specifically what we are still looking at is the so-called hardware. And we have emphasized the fact that when it comes to hardware, the crucial hardware components that are involved are so-called computer systems. And there's essentially two types of computer systems. So you have your microcomputers that are typically used by MIS users. So these computers would be used to access MIS platforms. And then you have the server computer systems. Server computer systems are designed in such a way that they can handle significantly larger workloads in comparison to microcomputers. And we discovered that your server computer systems are actually used to host and deploy so-called management information systems. So the example we've been referring to, the so-called ZSPIS, this thing here is ideally installed on a server computer system. And if you just go online really and you just look up things like server computers or something 2023, you have a sense of how these things look like. And typically your server room we'll start with the server so that people have a sense of how this looks like. So your typical server room, if you have servers in your organization, I'm sure if you've been to a server room, it's cold, extremely cold actually, and you'd have so-called server racks, right? So something similar to what you're seeing on the screen right now. It may not be as sophisticated as what you're seeing depending on the sheer scale of the organization, but the idea is the same. All right. So in essence, your MIS would be installed on such a computer system. Now, what we discovered when we were interacting yesterday was that, in fact, the option that we have, right, as opposed to purchasing our own server infrastructure and setting up a server room, a dedicated server room, a temperature-controlled server room, what we can actually do is we can rent server space or server computer systems. This is the essence of cloud computing. And we actually spent a great deal of time outlining or explaining the three different types of cloud computing offering. So-called software as a service, where what you're renting is essentially the application itself. And then you have your so-called platform as a service, where the things that you are essentially renting the environment, the deployment environment, and then you have infrastructure as a service. So what we're explaining here is more or less like similar to I think we can still use the rent analogy here, right? When we are renting, I don't know how many of you have used so-called Airbnbs and all those things. When we are renting spaces where we can stay, there's different ways of renting space, right? If you think of a hotel, for instance, in a hotel, they'll provide you with food, so you're paying not just to stay at that hotel, but they'll provide you with, it's like breakfast. Sometimes if you're lucky, even, supper or something. That would be your SaaS. But in these places that we rent, those of us that don't have houses of our own, such as myself, yours truly, we rent the entire house, but we cook on our own, right? So the landlord will give you access to a house. You buy your own furniture. I guess we can forget about the furniture. So you can rent a house with the furniture. In some instances, you just rent a share one, so you have to buy your own furniture, your own beddings, and all those things. There's a similar analogy anyway. So we discussed this and we looked at the advantages of all of these different offerings. So before we transition, I wanted to find out if people have thought about our discussion and if you have any specific questions or perhaps thoughts about this. I suppose there are no questions or thoughts. Maybe we can continue. I'm just worried that surprising here that we have very few people present. Maybe I can send through a reminder and just tell people that we have class or something. I don't know what's happening here, but that's okay also. Let's just say this information is available in the course notes document. This is good enough or something. So anyways, if there are no questions about our discussion of cloud computing, that's fine. This is probably going to come up again when we start looking at information needs analysis and requirements elicitation, really, as we are planning to have a management information system built on our behalf and deployed on our behalf as well. So it turns out, though, in addition to this computing infrastructure, so-called microcomputers and server computer systems, there are additional auxiliary hardware components that are required, right, for your MIS platform to function optimally. All right, and typically you'd be more interested in the hardware that either is shared amongst the people using the system, the MIS system. I am pretty sure that in addition to generating reports, one of the things that you find yourself doing is you'd have to print out the reports or something. All right? Printer is a piece of hardware. It's important. I mean, it's a standalone hardware component here, but it's nonetheless important, right? It's linked to the MIS. It's entirely possible that when transactions are being processed, if you look at a system like this piece, maybe there are additional or auxiliary hardware components that may be used as well. But in addition, the other crucial piece of infrastructure, and we discussed this during our discussion of the communication infrastructure, is hardware associated with the communications infrastructure itself. So I'm sure in your respective organizations, you've heard people from IT make mention of the fact that, oh, we have just invested in a new router, or oh, the switch is down or something, or oh, we need to buy a hub, right? All of these are hardware components. Specifically speaking, actually, these are peripherals, input-output devices, whose sole purpose is to facilitate the communication or the, I guess, receiving and sending of data to remote network nodes or from remote network nodes. All right. So again, these are some of the just some examples, your visual representation, some obvious examples of hardware devices that you probably are familiar with here, right? IP phones are quite common these days. Cost-effective way of communicating within the organization. Although these are being phased out because I think people are increasingly communicating using their own personal devices or cell phones or something. It's not uncommon in the environment I work in for me to get a phone call from a colleague, right? It's easier for them, I guess, that way. And you have printers as well. Again, the specialized pieces of hardware I was referring to, this image doesn't necessarily showcase exactly how these devices look like, the so-called routers, switches, and hubs, or even modems, but this is just a logical representation of these things. At your own time, I do encourage you, if you are not familiar with how a switch is you can look up things like network switch or things like network router or something, so that you have an idea of how these hardware components actually look like. So this is your switch here. Usually sometimes this would be installed maybe in an office space where you would be working, and then you have Ethernet cables that would directly connect your machines, desktop computers you work with this switch, right? With the idea of enabling you to transmit data or to receive data to a network node or from a network node, so a remote computer. Anyways, all right. I don't know if people have any thoughts about these auxiliary hardware components. This is just the last remaining bit here before we transition to our discussion of the software element. Just out of interest, can you hear me, by the way? I might be talking to myself here. It has happened in the past.
Yes, we can get you, sir.
Okay, thank you very much, sir. Great.
We can hear you.
Wonderful. Thank you very much. All right. So in as much as we've introduced this whole notion of like so-called MIS platform, management information system, but it becomes important for us to discuss a management information system is a piece of software, but it becomes important for us to discuss generally, right? Discuss this whole notion of computer software, because it turns out that as you are using your so-called management information system, you find yourself using other software components. A classic example of a software component that you cannot ignore when you're using an MIS platform is operating system software. Because before you can interact with the management information system, your computer needs to be installed with operating system software. There's more, right? We keep mentioning that your so-called MIS platform is web-based, is it? Like the ZSpace we've been talking about. Because it is web-based, right? In essence, it's web-based because we access it via a browser, right? Before you can access it, because it's web-based, there's a crucial piece of software that you need, your so-called browser, right? It could be Chrome, it could be Internet Explorer, or perhaps it could be Firefox or something, or Safari. In essence, all of these are examples of software, right? Software that you cannot run away from when you're interacting with an MIS platform. So in essence, what we're saying is during this whole process of collecting summarized data, because this is one of the core functions of MIS, the dissemination of information. Once this data is collected, you synthesize it, and then you generate reports. In an organization, you have a series of computer software tools that are used, right? Together with other information system components. All right. And it turns out that this broad spectrum of computer software can actually be categorized in so many different ways. So for instance, we have some software that is, web-enabled software, right? Enables you to gain access to or rather, these are software tools that are hosted or installed on remote computer systems. You have so-called desktop applications. So these would be software tools that you have to explicitly install on your microcomputer, for instance. We have mobile applications. This is broad array of software tools. It turns out that in as much as we have different types of software tools, they can be categorized in a certain type of hierarchy. All right, we're going to discuss this hierarchy here broadly in the next couple of series. But just to mention that fundamentally, the so-called software is nothing more than a series of instructions. So you would have heard people discuss the fact that ideally the way a computer works is the computer software is used to direct the hardware. In fact, in some instances, there will be mention of the fact that what we make reference to as a computer is actually a combination of so-called hardware and software, right? So the two can't exist in isolation. They complement each other, and they complement each other with each other. They complement each other by having software direct the hardware on what exactly should be done. Okay. So again, the visual representation here just showcases the so-called instructions. It turns out that they are of different types here. So people that will prepare these instructions, so-called programmers or developers, can choose to write these instructions using different notations, essentially. And these different notations will have different advantages, but that's not our focus in this particular course. What's important is for us to appreciate that the fact that irrespective of the type of software you're looking for, it could be operating system software like Windows, or it could be a social protection management information system like this ZSpace, or it could be an email application like Gmail. All of these things are composed of instructions. So a programmer will typically prepare these instructions, and the end result is what you and I will normally see as maybe Firefox or ZSpace or Gmail or Facebook, or Twitter or something. All of these things are essentially made up of instructions. Anyway, again, just to reiterate the point already raised here, the fact that the software itself is written by individuals like yourself and me. They're called programmers or developers. Sometimes they're referred to as software engineers. It's the same thing. These are individuals who specialize in the art of creating software. Okay. And usually they will use a specific notation, a predefined notation. This is what is referred to as a programming language. So it's a specification on how these instructions should be organized so that they eventually result into what we call software, ideally. So this notion of software developers will come up during our discussion of information needs analysis, because as you're planning, when you sit down and you're planning to have an MIS platform built, what you will discover is that the process of identifying, let's say, how much it's going to cost you will in part involve how much money you will pay the people that will create these software applications or these software tools, right? But the key takeaway point here for now is that computer software is written by individuals called programmers, and these programmers will use a predefined notation, a notation which is specified using so-called programming languages. Okay. The other thing to note here is that, and we have a dedicated discussion, there's a module that is tied to this. These programmers, as they are writing computer software like ZSpace or like this core MIS that we've been referring to, what they will do is they'll go through a systematic process of doing this, right? So there's a recommended way of developing software. It's not necessarily prescribed, but it's recommended way of developing software. And the recommendation is there to ensure that the project, so the process of developing this software, is done within budget. So you don't want to go beyond the allocated budget. You want that whole process to be done within the expected time period. All right. And then you also want to make sure that the end result is of high quality as well, if that makes sense. I apologize. I think there's somebody who is attempting to call me, and it looks like an important call. Just a minute or two, please. All right, sorry about that. So in essence, this recommended way is what is typically referred to as the software development life cycle. There are distinct phases in this software development life cycle. The whole process is initiated during the requirements engineering process. Of course, there's prior planning before. But in this phase, what you do really is the people developing the software in consultation with the organization they're developing the software for will sit down and identify the project goals or objectives. That's the first part. And as part of that phase as well, what will be done is a series of so-called requirements will be identified. So you sit down with the key stakeholders or the people you're developing the software for, and you ask them, of course, in a certain special way, you ask them how that piece of software should be built. What exactly should the software do? And so if you are developing this piece of software for people from the Ministry of Community Development, for instance, they'll be able to tell you to say, well, we want this software to enable us to pay beneficiaries money. Okay, that's a requirement. We want this piece of software to make it possible for us to generate reports. And then you probe further and find out, what sort of reports exactly are you interested in, right? And they'll tell you, oh, we need to be able to generate payment reports and, reports about eligible beneficiaries and, people that have graduated or something like that, right? So the key thing, though, as part of requirements analysis or requirements engineering, is you are identifying the things that this piece of software should do. What exactly is it going to be doing? The next phase is so-called design, where you come up with a high-level representation of what this software, of how this software is going to be built. The closest example I can think of here is what happens when you're developing software. It's the same thing that happens when a house is being built. We know that the very first thing we need to do is we sit down with the person who are building a house and they'll tell us, oh, I want this house to have 3 bedrooms. I want the master bedroom to have a bathroom, right? I want a kitchen or something. I want a staging area or a living room or something like that, right? And they'll give you specifics like the dimensions of the master bedroom and these other spare rooms and all those things, right? Those would be the requirements. And then as part of the design, similar to building software, if you look at the house, you typically have house plans, architectural diagrams, showing the layout of these important things that need to be taken into account as the house is being built. Now, you and me know that there are some people that will decide to cut corners. They will decide not to pay an architect to come up with architectural designs, and the end result we know is usually things that will not really be that appealing. Anyways, so the design essentially will make it possible for you to come up with these high-level representations, different views of the software. Part of what you do is you would actually come up with so-called database design. So the logical structure of the database, how the data is going to be organized. If you're going to be capturing beneficiary details, how exactly are these going to be captured? Are the beneficiary details going to be linked to other information, like households, like payment information? If they are, how exactly are they going to be linked to each other? You do this as part of the design. And then finally, during implementation, the programmers would write the actual source code. So this is what these experts refer to as, oh, I'm programming or something, right? And then, of course, you also need to take into account testing. It's one thing to develop a piece of software like this, but the question to ask is, does this thing do exactly what we told these programmers that we wanted? So you have to test. There's different types of testing, but what's important is you sit down with the end users and you conduct what's called user acceptance testing. So against all those requirements that were specified by the users, you go through a systematic process of confirming that the system actually does what the users would expect it to do. And then finally, there's this continuous process. It's called evolution. Sometimes it's called maintenance. It's an ongoing process. Throughout the duration within which this piece of software is going to be used, there are a number of things that will happen. Like, for instance, the system users will approach the developers and say, well, there's this additional feature that we want, right? Or you will notice that there's something wrong with the system, unexpected behavior, the things we call bugs, for instance. So the developers will create a patch right? Or an improved version of the software, and then they'll deploy it. All of this happens after deployment of the software. So in essence, I mean, insofar as the implementation process is concerned, these are the 5 key phases associated with the so-called software development lifecycle. I hope this is clear enough. I don't know if there are any thoughts or comments about the SDLC lifecycle. I would especially be interested in finding out if some of you have been invited to participate in these requirements gathering exercises. Typically, these will manifest themselves as workshops, right? There's a workshop, the developers or the company that has been hired to develop the system for us wants to meet with us. We are going to camp at Ndozo Lodge or at Chamba Valley Exotic Hotel, which is where we were when we were gathering requirements for this UNZA HR system that is being built. So we sat there with the key stakeholders, and all the interested parties were giving us feedback. This is what we want the system to do. This is how we envision to use the system. I don't know, has anybody participated in this exercise or been a part of this exercise? I suppose not. Okay, that's okay. Anyways, so in as much as we are saying that software is, irrespective of the type of software, it's composed of instructions, and when you're developing this software, you go through, well, you use programmers who develop the software, and they use a notation which loosely is tied to a programming language, and additionally, there's a recommended process for developing this software. It turns out that this software can broadly be classified into 2 main categories. Okay, so we have so-called application software, which is what most of us use often, and the so-called system software. Okay, what's particularly interesting is, depending on the type of system software you're referring to, is for the most part, application software doesn't direct the hardware directly, so it goes through system software. If you remember, I mentioned that software and hardware work in unison in such a way that the software will direct the hardware, but it turns out that application software does not direct the hardware directly. It typically goes through system software. And for most microcomputers, the system software it goes through is so-called operating system software. This is one of the reasons why you need an operating system to be installed on a computer before you can use these fancy things like Firefox, Chrome, Zspace, Facebook, and all these things here. In terms of application software, so the application software really is a type of software that allows end users to perform specific computing tasks or problems. Right, so you'd use these to perform a specialized task. Like, for instance, for you to draft a document or to author a document, you use a word processor. For you to access web applications or websites, you use a web browser. For you to send and receive emails, you use email client software. All right, so these will be performing specific computing problems. In terms of the notation, if you remember at some point here, I was making mention of the fact that programmers will have a choice of the type of notation they would want to use. There are 3 broad notations, the so-called, high-level programming languages or programming language notations. There's assembly language notation, and then there's low-level language notations. What we're saying here is that typically application software tools, such as a web browser, such as your PDF viewer like Acrobat, will typically be implemented using a high-level programming language. This is not important, but I thought I would include the specific types of programming languages that would be used. Programmers usually will have a choice of which language to use. And in case people are interested, you may wish to know that programming languages. You may wish to know that there's actually hundreds, if not thousands, of programming languages. So people that specialize in the art of writing software have the option to choose all of these things you're seeing on the screen. I don't know if you've heard of people talk about things like, oh, Visual Basic or Java or JavaScript. There's quite a number of them. If you look at this Wikipedia page here, the first bit here is just showcasing these languages arranged in alphabetical order, right? Even I myself have not used some of these things. I mean, I've certainly used C++. I've used things like Python, right? I've used things like PHP, right? I've used things like Java, for instance, all right? I've used things like JavaScript, so there's a number of them. I'm going to send through this list for the benefit of those that list of programming languages. For the benefit of those that are just curious, I mean, this is not relevant to the discussion we're having right now, but I thought I would just mention, in some instances, when you are gathering these requirements, it becomes necessary for you to tell the programmer, to specify to the programmer, as you're interacting with them before they start building this, to say, we want you to build this software using Java or using JavaScript. Part of the reason you are doing that is, at some point during evolution, the maintenance of the software will be the responsibility of your IT team, perhaps. Because usually when you subcontract a company to build software for you, there'll be a support period, typically maybe 6 months or 1 year or maybe 2 years, after which that company will no longer offer you free support. So if you decide to involve them in anything you're doing, you pay them extra money. To avoid that, to avoid those additional costs, what you do typically is your IT team will provide input during requirements gathering, and they'll specify to say, our expertise in IT is in C# or JavaScript or Java. So we want this software to be implemented using a Java programming language. All right. This would be an instance, an example where you would be explicitly specifying the type of programming language to be used, essentially. Anyways, so that's that application software. We're saying it's generally implemented using a high-level programming language. Another point to note is typically application software will be designed, for the most part, most of these application software will be designed to run on specific types of computer systems. So this will be desktop computers, mobile devices like our smartphones, for instance, and in some instances, even server computer systems. So those things that you're seeing as icons, like your TikTok, if you use TikTok, or your Facebook app on your phone, all of those are application software, but specific subcategories of application software. All right. So we see that the point here is that we're saying that this application software can be further categorized into a broad spectrum of subcategories. We have mobile applications, right? We have web applications. We have desktop applications. We have USSD-based applications and all those things. And so we're going to go through these things one at a time. In part, by the way, in case people are sitting there and I hope you're not lost here, but in case people are sitting there and wondering, but why are we discussing things like, when our focus should be MIS, Management Information Systems, why are we talking about mobile applications or application software and USSD-based applications? Well, I would like to draw attention to the discussion we had when we were looking at, and I don't know if it's this discussion here, maybe it's not, but the discussion we had, I believe it was in module number, let me just go there. I believe it was in module number 2, it was, I think, if not module number 1. This is module number 2. I think it was in module number 1. One of the things that was highlighted in this discussion is the fact that, I hope this is it, here. One of the things that I had hinted, I'm just going to transition to the discussion at hand so that we don't lose focus of this discussion. I don't know if it was here or I think it's I don't know if it's here or there. I'm lost track here, context path. I think it's here. There we go. Application software, right. So one of the things we had discussed, if you remember, was the fact that, I'm just going to zoom in here or put it in full screen mode. One of the things we had discussed during this discussion, if you remember, is that a system like this ZSPIS management information system has different components. There's a component here, right, where we can see microcomputers here, a phone, a tablet, and a laptop, right? These microcomputers are used to collect data. And if you remember, there was mention of the fact that there's this COBOL toolbox that is used. Now, the interesting thing is that this COBOL toolbox, in all likelihood, is associated or is seen on this smartphone or a tablet here as an app. So you install it there. That app is an example of a mobile application. All right? If you look at this, the payments here, it's possible that in some instances, the users, I hope they've implemented this, maybe the beneficiaries may want to check payment details, whether they've been paid or not, using a USSD application. We know that the people are paying 33 cents per month may not be as fortunate as you and I, right? They may not have these mobile applications which you can use to install these mobile apps. So if they have a feature phone, the only thing they can do is use, the phone app to type in star, I don't know if it's 112 or something, hash, and then they're able to interact with this ZSPIS application or something. All of those things are examples of mobile applications. What we're saying here is that these mobile applications would be deployed on mobile devices such as smartphones, tablets, smartwatches, or indeed even so-called feature phones, right? Those things that will only allow you to make phone calls and send SMSs and perhaps access USSD-based applications. If you have a smartphone, you'd also find yourself using mobile applications such as mobile browsers. So most of you probably have installed on your smartphones like a Chrome app or a Firefox app or something, right? Those are mobile web browsers essentially. And you use them to access these different web applications like the ZSPIS application, just like you would if you are using your laptop. The idea is the same. It's just that those applications are optimized to run on a mobile device like a smartphone. But we see that there's another way of access, there's another breed of mobile applications. Typically, these would be accessed using your phone app, right? Sometimes when you're wanting to check your balance, you find yourself typing, star, what do I type myself? I think I type 114, it's been standardized, hash. You press the button that for calling here and you're able to see a balance. We see that we use a similar approach for us to buy bundles, right? 117. And then there's that menu that will come up that will showcase the different options that you have access to here. I don't know if people understand what I mean. It turns out that you can do the same thing for this management information system, because ultimately the different users of this management information system will find themselves interacting with this system in so many different ways, depending on whether they are collecting summarized data, depending on whether they're generating reports, and indeed depending on whether they are making payments to eligible beneficiaries. In some instances, it may be necessary for you to use mobile applications. I don't know if all of this is making sense here, but I'm hoping it is making sense. All right, so in some instances, some mobile applications would be designed to run on these computer systems that are associated with relatively larger or high form factors. So the screen will be high, like your laptop, and would be large, like your laptop and your desktop computers. All right. So applications that are designed for such computer systems will be referred to as desktop applications, essentially. And for the most part, what you do is before you use such applications, you have to download the application and then you install it, right? You double click and then you go next. There is, however, a variation for these applications. They are so-called portable applications. So they can be considered desktop applications, but you don't have to explicitly install them, right? You download the application and it can run without explicitly install it. In fact, in some instances, you can actually place that application on a USB stick. Yeah. I don't know if all of this is making sense to people here, right? But we see that we also have different types of application software called web-based applications. And these actually are closely tied to these so-called management information systems because of the nature of the application, right? Your typical MIS is supposed to be accessed by a number of users at any given point in time. And the easiest way of doing that is to make sure that that application is web-based, right? So that whoever is interested just opens up their browser and then they specify the URL to use to access that application. Okay. The other reason why an MIS application would have to be web-based is because typically it needs to be installed on a dedicated computer system, which we introduced as a server computer system. And because you're installing this on a server computer system, which may be on the network, but located away from where the end user is, obviously it has to be web-based. In addition, you have so-called web services. Now, web services will come up when we start our discussion of interoperability. Again, I want to draw attention to the discussion we had when we were looking at this high-level representation of the different elements associated with this piece. We discovered that this piece actually interacts with other external systems like Airtel systems, MTN systems, Zanaco systems. When you're making those payments, these are not done offline. They're done, I hope, they're done using the system itself, using this piece. That is possible because these two systems, or this piece and these other systems, speak to each other. The idea of one system speaking to each other is made possible through so-called interoperability, right? So there are protocols involved. In essence, a system like this piece or a system like MTN Money or Airtel Money would be implemented in such a way that it has web services, a standardized way that other third-party systems can take advantage of to speak to that other system. In essence, to gather information or to send information to the other system. Generally, this whole notion of interoperability or web services, it happens at the application layer. So you don't have an end user interacting with these web services. These web services would actually be used by other software systems, ideally. Okay. Away from that, and I think this is an extremely important conversation to have, still dealing with application software, we have so-called software tools that are referred to as, add-ons. Sometimes they're referred to as plugins, extensions. In other circles, they're referred to as modules. The idea behind such applications is you want to make it possible for people to be able to extend the functionality of an already existing software. This actually is especially the case when you're dealing with, let's say, software as a service applications. If you remember yesterday, we mentioned that the idea of a software as a service is you have this organization that will develop a generic piece of software. And that piece of software will be offered to different organizations using a subscription model. All right. So maybe Zambia will subscribe to that piece of software. So imagine a system like this piece, right? A system like this piece has been implemented by an organization and offered to these different countries as a software as a service. Zambia would want to use this piece of software in a completely different way as Malawi, as Mozambique. One of the ways of customizing that piece of software is to develop so-called plugins. So maybe, for instance, in Zambia, you may want to integrate this software as a service with Zoona. But Zoona may not be there in Malawi. I don't know if it's there. Or Zoona may not be there in Angola or Mozambique. So what do? Well, you can build a plugin. All right? You can build a plugin to be able to facilitate that. I do apologize, colleagues. There's what I think is an agent call that I need to pick up. I normally would ignore this call, but if you can just give me a few seconds to just answer this person. Thank you. Hi everyone. I am so sorry about that. I had to pick up that was an agent call. I normally don't pick up calls, but that was an agent call that I had to pick up. Just checking because I'd muted myself. I'm checking if you can hear me now. I hope. Yeah. Don't know if people can hear me. Can you hear me?
Yes, we can get you.
All right. Thank you very much. Right. So I was just explaining, a scenario when you may want to take advantage of so-called add-ons, right? So if you, let's say you decided to subscribe to a Zispis application which was offered as software as a service, and you wanted added functionality, what you would do is you would develop an extension, an add-on, or a module that would be specific to maybe Zambia, Malawi, or Mozambique. And as luck would have it, this idea of extensions, I'm sure you've experienced this, right? If you use Google Docs, for instance, which I use quite often myself, what you notice is that a tool like Google Docs can be extended, right? It can be extended in such a way that, and these are bad examples I have here, but it can be extended. I'll showcase exactly how I extend it myself. It can be extended in such a way that you can actually, I wonder if there's an easy document that I can access it. You can extend it in such a way that you can have extensions, right? I don't know if you take advantage of this. So personally, when I'm creating documents, for instance, when I'm authoring documents in Google Docs, one of the things I do, right, and I'll have to delete this later on. This is just an example. This is just an example. One of the things that I would do is I'll be citing work. All right. Now, you and me know that when you're citing existing literature or something, if you're preparing an academic piece of writing, there's usually this obsession about things like, citation style and referencing styles and all of those. Well, Google Docs, because Google Docs and Google Slides and Google Sheets, these tools are used by millions of people that work in so many different sectors. It's implemented in such a way that it can be extended. So as an academic, because one of the things that I do is I cite existing work, what I could do is I can install, and I'm trying to see if I can maybe find a better, I'll just say UNZA website here, a better resource to cite here. For me to be able to extend Google Docs in such a way that enables me to cite things in the proper manner, what I can do is I can install a plugin. And by the way, these are all in your Google Docs. If you go to extensions, you'll be able to have a provision where you can install add-ons. What you're seeing here, Caption Maker and Captionizer and Code Blocks and PaperPower, these are add-ons that I have associated with my account. So every time I'm accessing Google Docs, I have access to these additional features. You will not have access to these things. So one of the features one of the add-ons I use is called PaperPower. And with PaperPower, when I'm authoring a document, bibliography, what I do is I can automatically cite these things. And I don't know if this thing is working here, but I was expecting this to have been contextualized by now, but it appears it's not working. How sad. But I guess you can see here that I can actually access all of these different features. It says it's still working. I don't know why it's not opening up here. I wanted to showcase this. This is perhaps one of the easiest things that you can easily relate to, and perhaps some of you would actually start using this if you prepare your assignments using Google Docs. So observe, if I wanted to, let's say, cite UNZA, the UNZA website, I'll just come here using the PaperPower plugin, and I would then, and I apologize if I'm discussing something that you already know, right? But we may as well just discuss this whole notion of plugins. So I locate the resource I want to cite, and then I put the cursor on the position where I want that citation to appear, and then in the bibliography, I'll just say, so this thing appears there. I'll just say update citation and bibliography, and the bibliography will be automatically formatted on my behalf here, right under bibliography, right? Now, the way this extension works, the way this extended functionality works is I can do fancy things like, and I don't know where this has gone. I think it's gone at the bottom, so I would have to go somewhere here at the bottom. If you notice, it's here at the bottom of the page, but I can cut it and push it somewhere at the top where I have this section here. So it's been automatically generated like this. And I can do fancy things here, like, because I know that this is missing, I can specify to say, well, this is how this plugin works. I can edit the data and edit it in such a way that because there's missing information here, right? What resource is this? It's a website. What's the website name? Well, the website name is, I don't know what the website name is, but I would have to go to the UNZA website and check what the website name is. It's University of Zambia. In fact, the title here is supposed to be home. Well, website name is University of Zambia. So I'll update this information. The author is University of Zambia. When was this published? Or I'll just say maybe it was I'll just speculate here, 2020 or something. When I save this data, when I come back to this plugin, when I hit this update citation and bibliography, the missing information like ND here will have a date instead of an ND because I've now specified the date, right? And we see that even the formatting of the citation works. And again, the way this plugin or this extension works, the way this add-on works is I can change the citation style. If the lecturer or if the journal says use APA, I'll change this. And the moment I update this, the the referencing and the citation style will automatically change. So I don't have to manually do all of this. Now, the key thing here is, and maybe this may not be very intuitive, I'll use something we commonly use in my line of work. It's called ACM. So ACM, the citation is in brackets with a number here. If I save this and I update, you will notice that the bibliography formatting will change, including the citation. So this list in the bibliography will be enumerated. There will be a number in square brackets or something. But the key thing here, right, is that I'm able to do this because the functionality of an already existing piece of software has been extended using an add-on. Sometimes it's called an extension. Sometimes it will be called a plugin. And I think you do this in Word as well. In Word, you can actually install plugins and extensions. All right? I don't know if that makes sense. This is important because who knows, right? Maybe, I'm not sure here, I haven't looked into this, but it could be the case that this piece is implemented using a plugin architecture. If this is the case and you want an added feature, all you do is you go to the developers and you tell them, please implement an add-on that enables us to perform this functionality. I'm not sure if it's important for us to discuss this, but I guess it is important. One of the things, I'm speculating here, but I imagine one of the things you may want to do when you're using a system like this piece or an MIS platform is you want to do a projection. We are in 2023, in the month of August, we may be interested, we've generated reports for July. We may be interested in knowing roughly how much money do we project we will spend in July of 2024. This is a point in the future. Now, those of you that have done a bit of economy will appreciate the fact that it's a regression problem, is it? It turns out that there's this new breed of applications called, or there's this new category of application called AI-based models, or they are called AI-based applications, which you can use to predict things in part. Right? So broadly speaking, we can call these AI models. So you can implement a piece of software that will allow you to do a projection. By July of 2024, how many beneficiaries do we expect to have? You're doing a projection. The interesting thing about this sort of projection is it relies on existing data, past historical data. So maybe you'd look at patterns from 2020, 2022, patterns from this year, 2023, patterns from 2021, patterns from 2020, 2019. Using all of those patterns, you're able to do a projection. The specific AI models are referred to as machine learning, right? So you build these models in such a way that you show them examples of things you've collected, data you've collected in the past, so that you can infer or predict values into the future, ideally. And just to mention, right, that these AI-based applications are all over the place. They're actually embedded in your phone. I don't know if you've noticed this, but when you're typing on WhatsApp sometimes, in WhatsApp, the application you use, it's not WhatsApp, it will anticipate what word you want to use. So it turns out that it's learning from past words that you've used in the past, right? As you are crafting these messages you are sending to other people, there are AI models that keep track of what sort of words are you using the most, right? Also, I don't know if you've noticed this, these things are in emails as well. Every time I create an email myself, before I don't know if this is not going to come up, but depending on how I'm crafting an email, hello everyone, sometimes there's what's called smart compose, right? My email address will know beforehand that, I don't know why this is not working here. I really wanted to showcase that feature. I think you've seen it though. It will autocomplete, right? Like in my case, every time I type hello, most of the time when I type hello, it knows that it expects me to type everyone. So those words will automatically be generated on my behalf, right? So these are AI-based models. And I know, right, that maybe in applications like this piece, these features may not be implemented already, but it is possible. And interesting enough, when we invited Mr. Lusambo last year in this machine, is it this year? It was this year actually. There's this data mining course that I teach in the Department of Computer Science. We specifically requested that he talks about machine learning. And these are the things that he was talking about, to say they have plans to incorporate AI or machine learning into what they do, so that it's a lot easier for them to do these things that involve a lot of work. Like, I'll ask you a simple question. How easy is it, if you work in this with this sort of systems, how easy is it for you to just try and generate a report to say, oh, these are suspicious accounts, we suspect that these beneficiaries are not supposed to be there? Well, if it's something that requires a lot of effort, you can build a machine learning model, right? A model that will be able to predict using a number of features here to say, we suspect that this beneficiary here is suspicious. We'll use the word ghost beneficiary, right? Anyway, key takeaway point here, I digress. The key takeaway point is this would fall under the broader confines or a broader category of so-called AI models. Very important. They're becoming increasingly important. Incidentally, I must say this, we do quite a bit of this with students I work with. So if you go to our research group website and you go to publications, you'll notice that we've actually published work to do with machine learning and a bit of AI. Suffice to say that our focus has largely been on we work with a lot of documents. So specific examples of work we've done, in case you're interested, is you want to look at, where is that here? I guess it's in 2021, I guess, I don't know. You want to look at, is it 2019? This is weird. You want to look at this, for instance, this automatic classification of digital objects. You also want to look at this work we did with, we collaborated with our colleagues from the computer science department. The idea is the same. It doesn't matter whether you're working with documents or you're working with social protection data. You can build these machine learning models. I don't know if I mentioned this, but earlier this year, we were training colleagues from ZRI. We were training them on how to use Python to do these fancy things. So you can build machine learning models to do sophisticated things like project figures. I must say this again. There's a project I'm working on. We've built models that help us predict which students will fail. Well, not fail, but yes, students are more likely to fail. And so what do we use these models for? Before the students can fail, when we identify to say this person is more likely to fail, before they fail, we can come up with an intervention to say, well, we shall have dedicated sessions for these students that are more likely to fail or something. Listen, this is an exciting piece of a category of computing here. I hope you take a keen interest in this. This is the future. I think there's a question from Ms. Namasiku. I thought I saw a hand up there. Is there a question, Ms. Namasiku? Please go ahead and ask away if you have a question. No, maybe it was not a question, but if it is...
Look, it was a question.
Oh, yes, please.
Yes, I wanted to find out the previous slides on the importance of software. From the knowledge, the limited knowledge that I may have on software, I know they cost quite a lot of money. So during the design and implementation and testing circle, the circle that you showed us, is there an input where, I don't know, maybe there is always this thing of saying, so like on the design, the software high level design, where this year there'll be Microsoft Word 10, then it will go to 12, then it keeps on building. So
yes.
the people that program, the programmers, do they anticipate, I don't know, using the AI software to say in maybe a few years, this software will be this much, so take precautions? I don't know. Is there, how do we deal with software issues? Because it's like they are changing every day. There's always this new thing, a new thing. So
Yes.
how do we continuously update those things?
Right. So it's difficult for you to so to answer your question, it's difficult for you to predict when the change is going to happen. But I think what's important is to understand, and thank you for that wonderful question. What's important is for us to appreciate when the change occurs. These versions, you see them everywhere, by the way. When you go to a piece of software, like this software I'm using, doesn't matter the name of the software, but it's called Ocular. If you go on About Ocular, you will see this number here. In this case, it's the number that's here is version 22.12.3. Right? If I go to Chrome, and I'll answer your question, I just want people to gain an appreciation of what is happening here. And I forget where Chrome has these things. I don't know if it's under settings and then it's about Chrome. If you look at Chrome here, it tells me that the version of Chrome I'm using is this. If you look at, if I was to ask you what sort of Windows you have installed, some of you will say, I have Windows 7, Windows 10. Hopefully some of you have Windows 11. Now, the evolution, that is part of evolution. Your question is tied to evolution of software. The evolution can be triggered by so many different things. The most common thing that triggers the evolution or the changing of these versions is feature enhancements. And I know we're using Chrome and Ocular, but I want to draw attention back to a management information system like this piece, for instance, right? Like this. As you are using this piece of software, if let's say you started using it this year, as you are using it and you become very competent in using the software, you begin to notice that there are missing things, features, important, in some instances, very important features that would help you become effective at what you do. So what you would do is you go back to the developer and you tell them to say, in as much as we paid you money and you developed this for us, but we've discovered that there's this thing that is missing. That's called a feature enhancement. When you have that feature enhancement, if the current version of this piece is, let's say, version 1.2.1, maybe the new version will be called this piece version 2.0.0. And typically, by the way, these numbers mean something. Putatively, by convention, if the first digit here, usually the versions will have either 3 components, sometimes there'll be more. Like if you look at Chrome, there are 4 of them here, right? 115.0.5790, this is crazy, but usually it's 3 of them. And the change in this number will mean something. So if you move from 1 here in the first digit to 2 here, it means you've added new functionality. In some instances, moving, if this middle number is one that has moved, right? Like maybe you move from this piece version 1.2.1 or version 1, let's say this is version 1.0.0, and then you move to version 1.1.0. Maybe this could be a security fix. So the other way software evolves is if there's a security bug. Like for instance, as you are using this piece, you begin to realize that, there are some dishonest people that have figured out how to game this piece. In fact, sometimes this could be internal people. We have a dedicated, by the way, colleagues, we have a dedicated discussion on security and data protection, usually the people that will do bad things are internal employees. I don't know if you've heard of these weird things like UNZA, oh, they're illegally changing grades or something. Or if it's a banking application, the programmers or somebody within the bank managed to tweak the system such that every time a bank client withdraws money, a Wanungwe is removed from that account or something. So the client won't know that it's a Wanungwe, but because that Wanungwe is removed from so many accounts, the dishonest people will make a killing here. That is a security bug. When it's discovered, it has to be fixed. The version changes. I don't know if I'm making sense here. So there are all these different triggers that will necessitate the version from changing. But again, to answer your question, it's difficult for you to know upfront when the version changes, unless if there are certain instances, and we'll discuss this when we look at the SDLC cycle. Sometimes when the developers are developing this software, they will prioritize the important things. So they will say, when we finish the first iteration of this piece, it will only be possible for you to generate reports and to maybe make payments and just check the list of beneficiaries. The next time we'll add new functionalities, you'll be able to check. I'm trying to see. You'll be able to maybe change beneficiary details and whatnot. You can plan for future functionalities that were not previously added. So you plan for them. You say, we will do this maybe beginning January next year, so that by the time we get to the middle of next year, we would have rolled out that functionality or something. I don't know if this is making sense, but the AI tools won't help you in any way. I hope that was helpful, but wonderful question, by the way. Thank you. I'm not sure if I answered Ms. Namasiko's question here.
Yes, Doc, you did. So meaning the add-ons that you were talking about is not something that can be done manually by the IT personnel in the organization. It has to be done by the original programmers. Great. For example, you said if you notice that there's a problem or there's a security bug that needs to be dealt with, so we can't wait for up to next year to change that. Can it be done? Is there provision for that change to be done now than to wait?
Great question. So what you're touching on, by the way, is tied to, and these are things that people that hold the sort of positions you hold would be responsible for. What you're discussing is to do with what's called end user support. You see, when you're developing software, right? There's two options. If let's say we're developing a management information system, if you have a competent team, you can develop in-house. So UNZA does this. UNZA has a directorate called CICT. Within CICT, there's a unit or a department called systems development. They develop software. They are paid to develop software. The other option is you contract people to do that. This is usually the most common option because it's expensive for you to hire people whose sole purpose is they're on permanent and pensionable. They're holding permanent and pensionable positions, but their role is to develop software. You don't develop software every day. I mean, you agree with me that you don't develop software every day. But the organization that you contract to develop software for you may develop software every day because they develop this software for different organizations. The common approach is you hire people to develop software because, by the way, people that develop software are quite expensive as well. This is an expensive endeavor. If you go the contract route, what you can do is you may have people within IT that may not be developers, but have the knowledge of how to develop software. If you have such people, so maybe their day-to-day role is end user support. The system is down, this piece, go and fix it. We can't make payments, they follow up. My computer is not working, they follow up, right? Those people will have the skill set required to write the add-ons. So if you go the route where you hire a contractor there will be a support period. Usually, the rule of thumb is to say, we will support you for the next 6 months. After 6 months, forget it, we will not support you unless if you pay us more money, which is usually more expensive. So what you can do within these 6 months is your IT team will work in consultation with the contractor so that they understand how the system was built, so that in the event that an add-on is required, what will happen is the in-house team will develop that add-on. This it's not difficult to do this. And usually the only requirement is that the organization, your organization, will have to insist to the developer to say, yes, we know that there are hundreds, if not thousands of, I don't know if you remember this, of programming languages, but our IT team is only competent in Java. So because we want our IT team to be able to add new features and to create add-ons for us and to fix security bugs, please develop this software using the Java programming language. I hope that answers your question. So it depends. This is tied to support. And support can be very expensive. It is expensive. Part of the reason why UNZA, this project I'm telling you about, the human resource system we're developing at UNZA, part of the reason we're doing this is it's virtually unsustainable for UNZA to continue paying licensing fees, which is why we've decided to build our own software. In the long run, we'll be able to save a lot of money, actually. I hope that answers your question. I hope. I don't know.
Yes, it has. Thank you.
Yeah. All right. Okay. By the way, I would like for you to really seriously look into this space of AI models, right? Because if you look at your typical social protection system, and I do apologize that we keep referring to something like this piece, which is to do with like these social protection programs, but we know at the back of our minds here that but that also social protection management information systems they come in various forms. There's so many of them out there. What you must appreciate is the fact that the things we do when we're in middle management or upper management have changed, right? We need to project figures. Usually, when you're projecting figures, you really can't run away from the fact that you need to use, machine learning models or these artificial intelligence models. AI is short for artificial intelligence. There are so many of them. I mean, incidentally, the reason why I have ChatGPT, I don't know how many of you have used ChatGPT here, but it's an example of an AI model, right? This is the future here. And if I were you, I would be taking a keen interest in, at least at a very high level, understanding how these applications work. Of course, for the purposes of MSP 5012, the reason we're talking about these AI models is simple. We are saying that they are an example. It's a subcategories of application software. That's it. But this ChatGPT, Smart Compose. This is the future, really. This is where this is the future. And the beauty of understanding this, by the way, is I don't know why ChatGPT is failing here. I don't know how many of you have used tools like ChatGPT and Google's Bard or something, right? This is the future here. Tell me about social protection management information systems. I don't know how many of you have done this. Have used these tools. You don't have to Google anymore, right? These tools make it a lot easier for you to do this. If you spend time and you read up on how these tools are created, it's quite interesting. These are called large language models, by the way, in case you're interested. But they are trained on huge quantities of data, books that are available online, Wikipedia data, right? So if you notice here, they are saying here that social protection, key features of social protection management information system is data management, beneficiary registration, payment and disbursement, monitoring and evaluation, integration and interoperability, most of the things that we are talking about here. This is the future here. It's unfortunate that this course doesn't have the provision for us to go that extra mile to talk about these things, but that's okay. I suppose. I don't know. There's more, right? There's this breed of application software called scripts. Now, relative to social protection systems, during our discussion of this component of management information systems called people, you will notice that we will introduce a group of people that are responsible to manage these social protection systems. They're typically called systems administrators, or sometimes application administrators. The people you call when the system is quote unquote down. I can't access this piece, or this piece is too slow. You've been given a number to IT. Those people are called systems administrators or application administrators. For them to be effective at what they do, they sometimes use this category of application software called scripts, right? These are short, short programs that will have instructions that help in performing repetitive tasks. Sometimes the task could be as simple as automatically backing up information so that when the server is stolen or if it goes down, I don't know if servers are stolen in these organizations. Do you hear about that? Lusaka City Council, you heard about that? Computers stolen. I thought that was a joke here. I'm like, but excuse me, do you not back up data, right? This is a scam here. It's just people that would want to, I don't know if you remember this, colleagues here, but there was a time when it was all over the news. I thought it was this year, it was last year or something. So you never know, maybe the server where this piece is hosted is going to be stolen and you lose the data. Before you can lose the data, these people called application administrators or systems administrators would have backed up the data and they will recover that data or something. Anyways, so the scripts. Excuse me. All right, sorry about that. I was choking there. I don't know what was happening, but that's okay. All right. So there's another group of application software. Now, again, relative to this piece, this would typically be used when you're building this piece. So here's the thing: when you're building an application like this is so complex, right? And I want to draw attention to this architecture, for instance. Very complex. There are so many moving parts here. There's like payment gateways, right? Software components that will facilitate you sending money. There's components that will enable you to keep track of what is happening on the system. It's called an audit trail. It's a security feature, right? Who did what, right? If Mr. Brenton, for instance, works on this system, what things did this person do in the month of July? This is how people get caught, right? We've had cases, I've heard of cases at this great institution of ours where certain people apparently were changing grades, right? There's an audit trail. What did you do or who changed these grades? They will see you, they'll find you. Who dispersed these funds to this beneficiary when they're not eligible? All of those components, right? They're complex to build or they take a lot of time to build. But it turns out that software developers have figured out a way of becoming efficient at doing that, at building software. You can use so-called reusable components. This is the essence behind libraries and framework. Essentially, a starting point, right? So that you don't start building things from scratch. And if you think about it, when you're dealing with software, like let's just look at management information system. We know that irrespective generic MIS platform or system, irrespective of the type of MIS system you have, whether it's social protection, whether it's in the higher education sector, there will be reports. People will need to log in and log out. So instead of you starting from scratch, you can use frameworks or libraries that will help you quickly build authorization and authentication modules. All right. So this is the essence of libraries and frameworks. And of course, here's the thing here. We touch on data protection, and we discuss malicious software at a later stage. But I thought during our discussion of application software, I would point out the fact that these malicious software tools we keep hearing about, like viruses and Trojan horses and ransomware. I gave an example recently of what happened to NAPSA, right? They were hacked apparently with ransomware. I don't know if you've heard of ransomware, but the idea behind ransomware, universities, I'll say bbc.co.uk. The idea behind ransomware is these malicious users, people that are very bad people, I guess we can call them, although bad is relative here. As far as they're concerned, I guess, who comes up with this definition of bad or good or something? But what these people will do, right, is they will write application software that is designed to encrypt your information. So you won't have access to that information. The only time you will have access to that information is when you pay them money, a ransom, which is why it's called ransomware. And I wish I could find some examples of certain universities that have actually paid money to do this, to gain access to their data or something. It's quite fun to look up some of this information. I don't know here, but I wish I could find examples of this. But what's important is that this so-called malicious software is actually application software, right? Because it's performing a specific task. The person who writes or uses that malicious software has the intention of doing a bad thing. From their point of view, it's application software. So I thought I would mention that. And one of the reasons, again, we're mentioning this is because we have a dedicated discussion where we look at data protection. Anyways, so there's, I wonder if, I think we can still finish this. It's a short discussion of system software. I don't know if there are any questions about application software. If you think we've left out something, a category of application software that you'd wish for us to discuss, something that has attracted your attention in the past or something. Anyway, if not, so if you remember, we had mentioned that software is classified into application software and system software. Application software is used to perform specific tasks, user tasks, end user tasks. Well, system software is there to help with the coordination and management of hardware and applications. For instance, the reason why you install operating system software like Windows is so that when you have installed a number of applications, your operating system software will be used to manage those applications. Like, for instance, how will the computer know how to distribute the finite computing resources? Application software. Also, in some instances, this application software that you use to make certain interesting configuration details. If you are left-handed, I like using this example, and you're using a mouse, you would have to configure the mouse so that your left click is not the same as somebody who is right-handed. That configuration change is done by software, system software, and specifically it's called utility software, by the way. Anyways, but the key takeaway point here is system software really is there to help with the coordination and management of hardware and application software. Just to mention here that this, system software is typically implemented for a specific hardware architecture. So your system software on your phone cannot run on your laptop. It can't run on a server computer system. And just to also mention that these are classified into, let's just say 3 broad categories. There's operating system software, which we're familiar with. There are so-called language translators, and then there are utility software tools or programs. Okay. The utility software tools are the tools that you use to just monitor your system. Again, relative to the MIS here, you begin to realize that if you have this MIS platform that is used by a lot of users at any given point in time, Sometimes it will slow down, like when you call IT to say the system is down. What IT does is to troubleshoot the problem, to fix the problem, they use utility software tools to analyze the system. Right, so they will look at the load, right? They'll look at how the computing resources are being used. So you're using utility software tools to do that. And fundamentally, what these I used to do is you fundamentally use them to either manage or monitor your applications or your computer system, right? And again, some of these things are just speaking to the motivation for why you might want to use, utility software tools. This is especially the case for server computer systems. This is applicable to us, by the way. So your utility software tools will be used. They'll be used. Where is that thing here? Ooh, they'll be used on this server, the thing in the red bounding box, to troubleshoot problems. The server is down. Utility software tool. Why is it down? Anyways. Some other points here is these are things we've already discussed, like the fact that you see these services, a software system like ZSP, or any social protection management information system, needs to be available 24/7, right? All the time. If it is, you need software tools that will be able to help you monitor if the server is up and running. If it's down, maybe you get an automated alert from this utility software tool to say the server is down. Anyways. And then these language translators are just there to translate the notation of instructions from one notation into the other. So remember, I mentioned that programs, right? Program instructions are in different notations: high level, low level, assembly notation. Well, you can use a specialized piece of software to convert in between these different notations. That piece of software is called the language translator. So these language translators would be used by developers when they're developing this piece, or a social protection management information system. Anyways, and then you have so-called firmware. And again, firmware will be there to just support maybe the server computer system. What's important here is that your firmware really is designed in such a way that it rarely changes. So it sits in a particular slot in memory called non-volatile memory, essentially. Takeaway point here is that this just is there to make sure that your computer or your server computer system is running optimally, ideally. For those interested further in this, when you switch on the computer, one of the things you'll see is that black window and some funny white text that comes up right before your operating system boots. That is firmware. That firmware is called the BIOS. All right. Anyways, and then you have operating system software, which really is there to just help you manage the computer hardware and applications. There's quite a number of things here to unpack. But just to give an example of some management tasks that you perform, things like file management. I want to create a new file, operating system, file management functionality. In some instances, it would be obscure functions like interprocess communication. When you are running a piece of software like this piece, there are so many things happening, a number of software processes that are running. Communication between those different processes is overseen by the operating system. And anyways, I mean, the whole point of discussing operating system software for the purposes of what we are discussing in USP 5012 is to underscore the fact that this piece, or a social protection management information system, cannot run without an operating system software. All right. Again, just to, I guess, just try to tie the different pieces together here to remind us that, software, system software is the one that directly interacts with the hardware. Application software has to go through system software for it to direct the hardware. All right. And again, the most important thing is that irrespective of the fact that we're making a distinction between application software and system software, all of these things play a crucial role, right, in the effective operation, implementation, and management of your management information system. I don't have any thoughts or questions. I think we can leave it at that so that the next time we meet, we shall start looking at this third element of your IT or your information technological infrastructure, where we talk about things like computer networks and all that. I don't have any thoughts or questions about this. Things that you thought were unclear, perhaps. All right. If not, we can leave it at that. Thank you very much to those of you that attended this. I would like to encourage you to please find the time and go through these materials, because the other things that we're going to be looking at here will only make sense if you understand what we've just discussed here. All right. I will see you next week on Wednesday. Enjoy the long weekend, and thank you very much.